So this brings us back kind of to where we started, right? Go ahead.
Yeah, Ptolemy's system was very accurate as well in terms of predicting what was going to happen. It was a valid mathematical statement of the phenomenon, but it turned out to not be the correct basis for the solar system.
I
And
would
this is,
not say that was a correct statement.
well,
Ptolemy's system could be set into correspondence with observations that had already been made. But if you tried to predict the future, it became inaccurate extremely rapidly.
Hmm.
And this created practical problems for the astronomers who were actually trying to deal with the most difficult problem, which was predicting the motion of the planets. The planets got out of alignment with the epicycles very rapidly, within months. And for the position of the moon, it was even more rapid. And there were clear, well known contradictions between dimensions of the moon, the apparent diameter of the moon, and the predictions of the theory. Because if you took literally that the moon was riding these epicycles, the moon would be much closer to the Earth at the perihelion than at the aphelion.
I think
And
that I'm
people knew from
more
ancient times that the change in diameter of the moon was very small,
I
not.
think that maybe instead of pointing to like the Ptolemaic system, I know that Tycho Brahe came up with a system that had like a small orbit for the Earth at the center of this. No? You're
No, no,
shaking your
that
head.
that Simon came up with that small orbit thing.
Oh, so for Tycho, for Tycho, it was just at the center. But it was basically like the Earth is at the center, the moon orbits it, and then there's the like two other systems that
Right. But
orbit it. And so it's like it gives you something. I think that Brahe's system was like a little bit more accurate in the sense of predictions. Because I think so this is what's crazy. And I think that this is relevant to the point that we're discussing here, which is that I think that you can, standing on Earth, accurately model a version of the solar system that has the Earth either at its center or very close to its center. I think you can mathematically chart that out. It's not going to be a parsimonious explanation because you're going to have a lot of really weird motions, like you're going to have all these weird trichoidal orbits.
but
But
that
I think that you can make that. And the point that you're making here is that you can have a mathematical model that is accurate, but it isn't true because
no,
there's
I'm
another
not
one.
saying that at all. I'm saying it it can be made to fit. It is a mathematically true statement that any mathematical model can be made to fit an existing set of data with enough what we call free parameters.
Mm,
So if you have the data, you know the data, it's been collected in the past, then you can fit a model, which means that that fitting to past data is not a test of the validity of the model because you can always do it. The test is to predict data after you have made the prediction. And that's what makes science useful. If it was just explaining what we already knew, it would be just so stories like
So this is
Kipling.
this is
But
what's
to make it useful, just let me finish, it has to predict the future. That's what's useful to us, to know that the plane will take off and land us in Paris. As I've said to people, including scientists, who say, oh, science is just another mythology. It's just another way of knowing. It's no better than the Bible. And I said this to a scientist who was in an airport with me. And I said, honestly, Alan, if you really believed that, I don't think he did, I don't advise you to get on that plane because it's nothing but mythology that's keeping it in the air. So that's the difference between science and Ptolemaic method. Can you predict the future? So what happened with the Ptolemaic system and its great, aesthetic appeal of these perfect circles. The Ptolemaic system had really three elements. One is the Earth was the center of the universe. Two was heavenly bodies are perfect, so they must move in perfect circles. Three was, can't describe the exact ideological justification, but heavenly bodies have to move at a steady pace. So there's no real change in the heavens. That became a problem. Tycho Brahe had made very accurate observations without telescopes of the motion of Mars. It became impossible to predict the motion of Mars with the Ptolemaic system. There were always mistakes, no matter how many epicycles you added. Kepler inherited Tycho Brahe's data. And he said, I know how to do this. Throw out these circles. The real ideological thing is the
The
perfect
ellipse.
solids. The perfect solids. So these had been discovered by Greek mathematicians, the icosahedron, the isohedron, and so on.
And this is downstream of like another mathematical cult, right? Because
Right,
this was all like the Pythagorean mysticism
right.
of
All
shapes that can be
Pythagorean.
arranged.
And Kepler was really a good Pythagorean. So he made these elaborate models. And guess what? He couldn't predict the, the location of Mars. So that was when he underwent his scientific revolution. He said, mathematics or no mathematics, I really want to predict the, the Mars. And Mars was the toughest one in retrospect. We know why Mars was the toughest one, because it was the most elliptical orbit. It was too hard to track Mercury because it had this habit of getting close to the sun in the sky. But of the outer planets, Mars had the most elliptical orbit. So that's why it was giving everybody the most trouble. And Kepler made this brilliant decision. Okay, mathematical beauty out the window. They're moving in ellipses. And he had this tremendous insight. I don't know enough about his detailed history to see how he got to there. Like, you throw out the mathematical model and you base it on the ellipse as a way to predict the motion of Mars. And then he could predict the future motion of Mars with the simple model that everything was moving in ellipses. So it wasn't even primarily the shift to the Earth-centered. It was obvious that it had to be sun-centered because one of Kepler's laws was that the orbits of the planets were ellipses with one focus being the location of the sun.
Our videos come out of LPPFusion's research in fusion energy, which will power a future with abundance for all, with a clean, sustainable economy and environment. Goods, housing, and infrastructure would be extremely affordable once fusion kicks in. Fusion energy is the key to an advanced future. Support fusion research. The link's in the description. And thanks.
So, that was a huge step in the direction of junking the Ptolemaic method. So that's exactly the problem we have with cosmology today. Today, the Big Bang Theory makes tons of predictions that are provably in conflict with at least a dozen different data sets. And when this happens, and when this has happened repeatedly since the 1970s, instead of saying the Big Bang Theory is wrong, which is the scientific conclusion, that it's not valid, that the universe isn't expanding, they do the Ptolemaic trick. They say, well, we're going to alter the theory, always making it more complicated, and fit the data we already have. and produce new predictions, which are always going to be wrong.